I've got an itch I can't scratch, I'm missing a piece that completes a whole part of me, an open wound scar to see. Everybody come here, gather round, welcome to the freak show, the best in town.
All right, hey, welcome back. Strap on your seatbelt and get ready to learn. I hope you have your math notebook out, ready to take some notes, because that's the best way you're going to learn. So here we go. If you're not ready, go ahead and pause it and get ready, because I'm about to get going, because we're talking about math. All right, let's take a look at this this equation here. We got 4 times x plus 3 equals 20. So how can we solve this? Part of solving complex equations, and you may be thinking, this is not complex. And it really kind of is and kind of isn't. But I want to show you the basics first before we get into some complex equations. So we all look at things differently, right? Differently. So I'm going to solve it what I call the traditional way. This is the way I teach it in my classroom. And then I'm going to go ahead and show you a different way, which I was taught a very long time ago. So let's get to it. So right here, we're going to take the 4 and we're going to distribute it back into this right here, the x plus 3. So that's 4 times x, and that'll give me 4x. And then 4 times 3, which gives me 12. And that is all equal to 20. That's the first step there. I have essentially rewritten the equation to look like 4x plus 12 equals 20. Now I can proceed and go, and so this becomes a two-step equation, so I'm going to subtract 12 from both sides. That becomes 4x equals 8. Then divide by 4 on both sides, and x equals 2. Okay? That is my final answer there. X equals 2. Now, could I have done it a different way? Of course I could have, because we all look at things differently. So let's take a look here. I'm going to go ahead and let's separate this with an orange color. And let's write the same equation here. We'll do it in black here. 4x plus 3 equals 20. So how can we solve this in the same way? Take a look back here. Notice where I subtracted 12 from both sides. Why did I do that to both sides? Because whatever we do to one side of the equation, we have to do to the other. Basically, we maintain the equation balanced all the way through until we simplify it in its lowest term. In this case, its lowest term was the value of x, which equals 2. And so notice when I subtracted 12 here, I subtracted 12 there. When I divided by 4 here, I divided by 4 there. Okay, well, what did I do here to get it started? I multiply, right? I put that back into it. Well, why don't I undo it? What? Undo it? Yes, undo it. If I did it by multiply, I'm going to undo it by dividing. So I have this 4 out here. I'm going to divide both sides of the equation by 4. I can do that first. So, oops, let me get a different color here. Let's get, how about rainbow? You feel like rainbow? Divide here by 4. That means I divide the other side by 4. Okay, that's going to be my first step. This right here is going to equal 1, leaving x plus 3 behind, equal to 5. 20 divided by 4 is 5. All right, next step, subtract 3 from both sides. Notice I keep doing the same thing to both sides. X equals 2. Same answer, but I did it differently. Maybe you like to do it this way. Maybe you've already been taught this way, and now you learn this new way. Or maybe you've done this way before, and now you can see a different way. Okay? So I hope you like this way, because it's really shorter, and this is kind of more what you'll see when you get into Algebra 2. I had some Algebra 2 problems in this lesson, so get ready. Let's take a look at the next one. Here we have 2x minus 8 equal divided by 10 equal to 6. Okay, so how can I do this? Well, I'm going to rewrite it. What I'm going to do is I'm going to take the denominator here, right? I'm going to take the denominator and I'm going to multiply. Notice it's being divided, so I'm going to do the opposite. And I'm going to multiply here by 10 and multiply here by 10. So let's do that as our first step. I'm just going to write it up here so it reminds us that we're multiplying both sides by 10. And now, if I'm multiplying by 10, please, you have a denominator. I want you to divide first. don't start multiplying the 2x minus 8. Don't do that first because we want to simplify it. So I'm going to divide 10 by 10, and that's going to equal 1, leaving the 2x minus 8 equal to 6 times 10. Now, why did I not divide here first? Because there's nothing to divide by. It's a whole number. The denominator would actually be 1. So there's nothing to divide by. So therefore, I just multiplied 10 times 6. Now, the next step here, let's go ahead and add 8 to both sides. And that gives us 2x equal to 68. Obviously, our next and final step is to divide both sides by 2. X equals 34. And that's it. That is my final answer. Oh, yeah. Can you hear the crowd going wild? No, seriously. Did you see how simple that was? It's not because I'm good at math. It's just because I learned some techniques that help me simplify these complex equations into a form where I can simply just turn them into two-step equations. I took this up here, this right here, and turned it into a two-step equation right here. That's all I did. All right? Hope you're getting the hang of it. And if I missed something I didn't explain in detail, write it in the comments section. Ask me. Let's take a look at this one. We have 4 plus x divided by 3 equals 9. Uh-oh. It's kind of the same here. We have a division problem right here, right? It's 2x minus 8 divided by 10. Well, here we have 4 plus x divided by 3. Let me go ahead and rewrite it twice. I'm going to rewrite it one time just to show you how more likely you would see it. It is 4 plus x divided by 3 equal to 9. Okay? More likely, this is how you will see it in algebra, algebra 2, and future equations, future math subjects. So now that I have it like this, well, notice it's kind of the same as this right here. The only difference is that this has an extra digit here. So what I'm going to do, the same thing I did here, I multiplied both sides by 10. Okay. I'm going to multiply both sides by 3. That gets rid of the fraction. I don't have to deal with complex stuff like that. So, but instead of just multiplying a side, well, I am. I'm going to multiply each term. This is a term, this is a term, and this is a term. Each one of those is going to be multiplied by 3, so let's get to it. 3, 3, and 3. So now I got 3 times 4. Remember, I'm not dividing because there's no denominator, and that's 12. Here, I can divide. I'm going to divide that out, the fraction. Now I'm left with just 3 divided by 3 is 1. 1 times x is x. And here, again, there's no denominator, so it's just 3 times 9 or 9 times 3, which is 27. I've rewritten my equation. Listen carefully. I haven't solved anything. 12 plus x equals 27 has the same value as 4 plus x divided by 3 equals 9. Same value. Different numbers, but same value. So now I'm going to go ahead and simplify it all the way. Let's go ahead and subtract 12 from both sides. And that's going to give me x equal to 15. And that there, ladies and gentlemen, is my final answer. I hope this is becoming easy for you. I really hope it is. And if it's not, let me know. What did I do wrong? All right? Make sure you mention it in the comment section. Let's take a look. Oh, whoa. Okay, we're going to skip this one because this one looks complicated. Yeah, right. Okay, I'm not lying that it looks complicated. It is complicated. But we're not going to skip it. That I was kidding about. So, let's get ready. Let's think about this. This, we have the square root right here, of 3x plus 3 equals 6. Okay, let's think about our math rules. What does a square do, a square root or a radical? What does it do? It undoes exponents, right? It undoes exponents. That means that if I raise some number 3 to the power of 2, which equals 9, I can undo it by taking the square root of 9 and that would equal 3, the original number that I started with. That's the purpose of a radical. So in that case, since I know that, okay, how can I use that to my advantage and try to solve this? Well, what I can do is take this whole thing right here, and I'm going to raise it to the second power. Well, why the second power? Because they're already taking the square root of it. So I want to undo it by raising it to the second power, which means if I did that, I need to take this side and also raise it to the second power. Does that make sense? I hope it does. So what happens here on this side? Well, since a radical undoes square roots, then that means that this square, the exponent of 2, and the radical are basically going to cancel each other out, leaving the 3x plus 3 behind. That's it. Now here, I don't have a square root, so all I have to do is take the 6 to the second power, which is 36. You see that? All right. Next, let's go ahead and finish it off. Once again, it's a two-step equation. Subtract 3 from both sides. We have 3x equal to 33. Divide both sides by 3. And x equals 11. Yeah. You must put a box on there using sound effects. Now, that may take some skill to learn, but I think you can get it. All right. Hey, that makes sense? Did you like it? Because I sure liked it. All right. Do we have another? Of course we have another one. Holy macros, Batman. What is going on here? 9 to the power of x equals 3 to the power of 40? Good God. Back to the Bat Cave to figure this one out. Okay. No, seriously, people. I'm not drinking. That's just the way I am. I love teaching. Let's take a look at it. We have 9x equals 3 to the power of 40. Once again, I'm going to rewrite it first. The question is, how can I rewrite it? Now, I can't take this 3 and I can make it a 9. But if I do that, I'm going to end up changing this exponent 2. Gets a little complicated. Just a little thinking. Or I can take this 9 and write it with a base of 3. Let's do that. How can I write this with an exponent? Well, simple. 3 to the power of 2. Now notice here, stay with me. 3 to the power of 2 equals 9. Okay? So all I've done is rewrite the 9. I haven't done anything with the x yet. All I did was rewrite the 9 as 3 squared, or 3 to the power of 2. Same value, 9. Well, the x, what do I do with the x? Well, it's an unknown value. I still don't know what to do with it. So we're going to put it right here because we don't know what value it is. So now I have 3 to the power of 2x. I want to show you that this whole thing has the same exact value as 9x. Same value, it just looks different. We rewrote it. Kind of like saying, write 1 over 2 as a decimal, and you write 0.5. It looks different, but it has the exact same value. All right, let's write equals 3 to the power of 40. Okay, now I have the bases are the same. Okay, Miss Medina, so what? The bases are the same. Now what? It looks even more complicated. But it's not, all right? It is not. Why? Because now all I have to do is really ignore my bases because the bases are the same. So all I'm going to do is set the 2x equal to 40. 2x equal to 40. Let's go ahead and finish this off by dividing both sides by 2. And x equals 20. Psh, 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 psh. Like that, the sound effects. Did you get that down yet? All right. I hope this makes sense to you. I explained every detail on how we got this. Now, x has a value of 20. That means that if I went up here and put 20 in here, 9 to the power of 20 equals 3 to the power of 40. Go ahead and put that in your calculator right now. 9, I don't have my calculator. Sorry, I would have done it. 9 to the power of 20, and see what answer it gives you. It should give you that same answer as 3 to the power of 40. All right? I hope you got some value out of this. Let me see. Oh, That was my last one. These are complex equations, people. Complex. But look how easy we made them look, right? Now you can look like a genius next time you're doing like, check this out, Mom. This is how much you owe me in allowance for cutting the grass. All right. Hey, I hope you like this, and I hope you really got some value out of this. And if you did, come on, hit the like and subscribe button, all right? And I'll see you next time on Math Quest. Have a good one. Bye-bye.